Alright, so in this problem, I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So to solve this, I'm going to first start by rewriting 512. So 512, this is the same thing as 16 times 32. And now I can write this as 2 to the power of 3 to the power of 4 to the power of x is equal to 16 times 32. Now 16 is equal to 2 to the power of 4, and 32 is equal to 2 to the power of 5. So this is why we wrote 512 as 16 times 32, because now I have 2 to the power of 4 times 2 to the power of 5, and notice how we have another base of 2 over here, 2 to the power of 3 to the power of 4 to the power of x. So now I can rewrite this as 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5. Now all my terms are bases of 2. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So right here we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5, which is the same thing as 2 to the power of 4 plus 5. And 4 plus 5, that's equal to 9. So 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And also, instead of doing all that, remember over here how we had at the start 2 to the power of 3 to the power of 4 to the power of x equals 512. 512 is equal to, well, we know that 2 to the power of 5 is 32, so 512 is 2 to the power of 5 times 2 to the power of 4, which is 2 to the power of 9. So we could just set at the start that 512 is equal to 2 to the power of 9, but some people don't know that 2 to the power of 9 is equal to 512, so that's why we had to do all of that. So now going back here, we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, we can say that m is equal to 3 to the power of 4 to the power of x, and n is equal to 9. So because these two bases are the same, this means that 3 to the power of 4 to the power of x is equal to 9. Now, 9 is the same thing as 3 squared. So now I have 3 to the power of 4 to the power of x is equal to 3 squared. And now again, I can use this property because both my bases are the same. So this means that 4 to the power of x is equal to 2. And now 4 is the same thing as 2 squared. So I get 2 squared to the power of x is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x, which is 2 to the power of 2x. This is equal to 2. Now, I'm going to use this property again. 2 is the same thing as 2 to the power of 1, so then because these two bases are the same, I get 2x is equal to 1. And now, if I divide both sides by 2, these two cancel out, and I get x is equal to 1/2. So now, to check, my original equation was 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. and we said that x is equal to 1/2. So I have 2 to the power of 3 to the power of 4 to the power of 1/2 is equal to 512. Now I'm going to work my way down from the top. So I first start with 4 to the power of 1/2. Now 4 to the power of 1/2 is the same thing as the square root of 4. And the square root of 4 is equal to 2. Meaning I have 2 to the power of 3 to the power of 2 is equal to 512. Now from here, 3 to the power of 2 is equal to 9. So I have 2 to the power of 9 is equal to 512. And finally, 2 to the power of 9, that's equal to 512, as we already said at the start. So we get 512 is equal to 512. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number, because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front, and I have log 5 to the power of 2. So I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143. So I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.